Hassler here. And so now that we've completed the Explorer, I want to talk about some new vocabulary with you and give you some examples so that you have something to reference when you go to work on the Check Your Understanding or the practice. And so we should have this third box available. And in this third box, we're going to write the words arithmetic. It looks like the word arithmetic because it is, but we pronounce it arithmetic. Sequence. Sequence. And so this is our new vocabulary word. And a sequence is just a list of numbers. Okay? And then this list of numbers specifically has a pattern that makes it arithmetic. So we're going to say a list of numbers created by adding or subtracting a common value, meaning the same number each time. And so let me give you an example of what I mean by a list that is arithmetic. Okay, so my example is 2, 8, 14, 20, ... just means that this list would continue on. Okay, and what I notice is that this list is created by taking the number and adding 6 each time. What that means is that I have something called a common difference, that common value. Instead of common value, though, in math, we tend to call it a common difference. And that common difference is equal to 6. So even though we use the word difference, common difference, it does not mean that we are subtracting. It just means that the numbers are different by a value of 6. Because I'm adding 6, that common difference is a positive 6. All right, so now that you have an example, we are going to come down here to the 1.2 examples and ideas, and I'm going to fill out a couple different examples for you. So we can see arithmetic sequences in a list of numbers, right? That's the example I had up above. And so I'm going to do another example. I had 20, 15, 10, 5, ... I notice there's a pattern here, and that pattern is that I am subtracting 5 each time. And so I have a common difference of 5. Negative 5, my apologies. But we talked in my math class today about how we are all mathematicians because we all do math, okay? And mathematicians, we are not lazy people. We are efficient people. And so instead of writing the words common difference every single time, I'm simply going to say D for common difference. D is equal to negative 5. That common difference is negative 5. Okay, and so from here on out, instead of writing the words common difference, I'm going to use the letter D to represent that. Okay, we can also see an arithmetic sequence in a table. And that's actually what you worked with in the Explorer. So in the Explorer, we had number of hexagons and number of toothpicks. And we had this table that we filled out. And we said for one hexagon, there were 6 toothpicks. But for 2 hexagons, there were 11 toothpicks. And for 3 hexagons, we had 16 toothpicks, ... And so we did notice a pattern here. I have a pattern here of going up by 1, but the reason is because I've created a list. And what this really means is the first number in my list is 6, and the second number in my list is 11, and the third number in my list is 16. What I really look at when I look at the pattern is what's happening in this bottom row of my table, okay? And what's happening in the bottom row of my table is that I'm adding 5. That's what makes this arithmetic. That in my first and second and third term, I have values that are changing by the same number. And so I would say that my common difference here is 5. Positive 5, because I'm adding 5 each time. Versus the previous example, the common difference was negative 5 because I was subtracting 5 each time. Okay. I've got another example. I'm going to move this so we can see it. We can also see arithmetic sequences in a graph. So I'm going to make a little sketch of a graph here. And on my x-axis, I'm going to put 1 and 2 and 3 to represent my first and second and third term. Okay. So typically what we see on a graph would be points. And those points, if arithmetic, would form a straight line. We don't connect the points. Okay. I could actually turn this into a table, and I could turn this into a table using x. We could say x and y if we wanted. My x is 1, and we'll call this 1, and we'll call this 3, and we'll call this 5. Okay, so at 1, I have an output of 1, and at 2, I have an output of 3, and at 3, I have an output of 5. So I could make a table from this graph, and then from that table, I could see, hey, it looks like I'm adding 2 every time. But I could also look at the graph and say, yeah, as I move over to the right, my y values jump by 2. As I move over to the right, my y values to get to the next point jump by 2. So I have this common difference of 2. So when we get to tables or we see a table, again, we could when we see a graph, we could create a table that goes with that graph to see the pattern, or we could count how I'm moving upwards or how I'm moving downwards. Okay. Lastly, I want to give you another list, and this list is 3, 6, 10, 15, ... And my question that I posed was, hey, is there a pattern? And is it arithmetic? And so what I noticed is that I have to add 3 to get from 3 to 6. And then I have to add 4 to get from 6 to 10. And I have to add 5 to get from 10 to 15. It does look like there's a pattern. It looks like I'm always adding one more than I previously added. So yeah, there's a pattern, but this is not arithmetic. So there are going to be times where you're asked, is the pattern arithmetic or not? And explain, this is not arithmetic. And the reason why this is not arithmetic is because we are not adding or subtracting a common value. I'm not adding the same value each time. I'm not changing by the same amount each time that add or subtract. And so we have to be able to make a decision and then justify the decision that we are making. And so this is a no arithmetic because I'm not adding a common value. There is not a common difference. Okay, so your job is to take these notes and use them to work on the check your understanding. And if you have questions, make sure you ask your teacher.